live stream. Basically, there's a way to balance this. Basically, I'm gonna just the thought process behind this is I've been kind of struggling to. Dang. Let's see, can we? I don't know if that works. I've been struggling to stay focused with studying for my builder's license. Like I'm studying every day, but I don't feel like it's quality study time. So I'm gonna go through these materials and I'm gonna teach it to the live stream, whether anybody watches, whatever, fine. But the point, I'm gonna put these. One sec. People are incredibly bad multitaskers. At least I am. I want to make sure it's not connected to my headphones. It's live, so I have no idea how to tell. Yeah, so this stream will basically be me studying this material and teaching it back to the live stream. And that the goal is to just hopefully help me dial in my learning, because I think we can learn a lot by teaching whatever we just learned to somebody else. In this case, this will be the audience. So this is the visual handbook of building and remodeling. It covers a bunch of building principles and remodeling, lots of visual diagrams, which is pretty helpful. Right now I am covering different types of wood species. I've learned that there are hardwoods and softwoods. Hardwoods are, I can't remember if they are dacious or probably messing up terms, but I don't know how to say things. Let's see if we can find it. Defects. Lumber. Well, either way. So moisture and shrinkage of wood. The amount of water in wood is expressed as a percentage of its oven dry as possible weight. So this is just how they measure how much it shrinks. Okay, so they take the benchmark when they put it in the oven and it gets as dry as possible. So they've taken as much water out as you can. That's their baseline. For example, 1 cubic foot of oven-dried red oak weighs 39.3 pounds. Okay. I'm just studying Divania. I don't know how to read words. I'm just studying my material for my builder's license. I'm a handyman. HE, hey, what's up? Studying. So trying to teach this material to you guys as a way for me to learn. That's kind of the mindset. Okay. 1 cubic foot of oven-dry red oak weighs 39.3 pounds. In drying from just cut or green stage, the sapwood loses 69% of 39.3 or 27.1 pounds of water. Dang, this is detailed. As wood dries, it first loses moisture from within its cells without shrinking. After reaching the fiber saturation points, cells dry. Further drying results in shrinkage. Okay, so there's a certain amount of drying that can happen in wood without it actually shrinking. Interesting. I didn't know that. So if it's like, so there's going to be a tipping point. So you can dry it out for 20%. It might not shrink at all. And then the next 20%, it will definitely shrink. So it just kind of depends. Eventually, wood comes to a dynamic equilibrium with the relative humidity of the surrounding air. Interior wood typically shrinking in the winter and swelling in the summer. Okay, so the moisture in the air will become at equilibrium with the moisture in the wood. So if the moisture content in the air is really high, the moisture in the wood will go up and vice versa. It's actually interesting. So you can expect if there's high moisture content outside and inside, that your wood is going to have a higher moisture content. And if it gets to a certain point, you might expect molding, and decay. I don't know for sure if that's how it works, but it seems like it is. Interior wood typically shrinking in the winter and swelling in the summer. So houses shrink in the winter and they expand in the summer. Interesting. Did you do your lessons? I don't know what that means. Average equilibrium moisture content ranges from 6 to 11% depending on the climatic region. I don't even know what that means. Huh. In the table below, the terms radial and tangential refer to the orientation relative to the growth rings. So I believe this is talking about the growth rings of wood, radial and tangential. I'm gonna have to Google Maps that, or not ChatGPT. Radial and tangential. They are terms often used in geometry, physics, and engineering to describe directions relative to a central point or curve. Radial refers to anything directed toward or away the center of a circle or curve shape. Tangential refers to anything moving along the edge of a curve or at a right angle to the radial direction. Weird. I'm not sure I understand that fully. But I'm gonna move on because I don't know, I don't want to get stuck on things. I would rather cover more material and get the gist of it because this is really in-depth stuff. A lot of this I'm not necessarily going to need. Um, Although typical quality stamp for pressure treated lumber, that I should probably know pretty in-depth. So pressure treating, pressure treated wood. Pressure treated lumber is a softwood lumber treated by a process that forces preservative chemicals into the cells of the wood. The result is a material that is immune to decay. So pressure treated wood, they put in whatever the heck into the wood and then it doesn't decay as easily. That makes sense. I've seen that in a lot of places. Pressure treated wood should not be used inside the home. Interesting. Inside the home. All of the major building codes require the use of pressure treated wood for the numbered applications below and illustrated on the following pages. So this is a list of the different applications of pressure treated wood. Wood embedded in or in direct contact with earth for support of permanent structures. Okay, that makes sense. So treated wood in the ground. Floor joists less than 18 inches and girders less than 12 inches from the ground. So if the floor joist is less than 18 inches off the ground, you want it to be treated. I guess that makes sense. So if you have a crawl space that is 16 inches from the ground to the top of the floor truss, okay, that makes sense, or floor joist. Foundation sill plates, or foundation plates, sills, or sleepers on a concrete or masonry slab in contact with the earth, and sills on masonry foundation walls. So if you don't know, the sill plate is the plate that goes on top of the footing is the foundation of the house. It's basically, it can, at least, yeah, it's basically a concrete pad for the house to go on. So any wood in contact with that should be treated. That makes sense because otherwise I believe the concrete, I don't know why this happens, but the concrete has more moisture and it causes the treated lumber to decay or normal lumber to decay. That's why you need treated. Ends of girders entering a concrete or masonry walls without a half-inch of airspace. Yeah, okay. So a girder will run across posts and then the floor joist runs on top of the girder. And so if the girder is running through concrete, it needs to be treated because Otherwise, it will rot it out because concrete has had more moisture. I don't know why it has more moisture. I don't know how that works, but it does, and it will rot it out. So it either needs to be treated if it's running through concrete or against concrete, or you can have a half-inch airspace. Wood structural members supporting moisture permeable floors or roofs exposed to the weather unless separated by an impervious moisture barrier. I have no idea what that means. Let's break it down. So wood structural members, studs, framing, that sort of thing, that would be a structural member. Supporting moisture permeable floors. So moisture permeable floors. So I guess that could be like a balcony would be a floor that moisture could permeate through. I think that would make sense. So like balconies are going to need treated wood. But if it's separated by an impervious moisture barrier, so for example on roofs, you have your roofing metal and you have your underlayment like waterproofing. In that particular case, you don't need treated, which again makes sense with what I've seen. Retaining or crib walls. I'm not exactly sure what a crib wall is. Crib wall in construction. Crib walls are gravity retaining walls made of interlocking boxes that are filled with granular material. They are often used for erosion control and soil stabilization. I think one of the reasons people like talking to me is that I don't use these massive words. And the reason I don't use them is because I forget them. Because it's like just big erosion, soil stabilization. It's like nobody talks like that in normal communication, at least in my experience. In my experience, it's like, hey, what's up, brother? And then you dab them up and fist bump them and be like, so what have you been up to lately? And talk about family, whatever. Anyway, off topic. So retaining or crib walls, that makes sense because a crib wall is basically keeping the dirt from sliding down. So it's going to be in direct contact with the earth, needs to be pressure treated. All weather wood foundations. Okay, interesting. So wood foundations need to be treated, and I think that makes sense. It goes contrary to the other. Oh no, that's specifically for structural members, but yeah, okay. So wood foundations need to be treated in geographic areas where experience has demonstrated the need. Wood members that form structural supports of buildings, balconies, porches, and so forth, when exposed to the weather without adequate protection from a roof, eaves, overhang, or covering to prevent moisture accumulation on the surface, or at joints between members. Wow, it's a mouthful. But this is basically saying in certain geographic areas, you need treated wood in certain places. I think that's the summary of that point. Okay, so that's those are the 10 places treated wood is used. Now let's look at the quality stamp that is stamped into treated lumber. Trademark. Okay, so this is a diagram breaking down what is on the stamp that's on pressure treated lumber. I've seen this at the hardware store. Trademark of the independent inspection agency supervising the treating plant. So this is okay, that makes sense. So if there's somebody inspects the lumber to make sure it's good to go for selling, their logo, their trademark is stamped onto the lumber. That makes sense. Assures that the piece has the appropriate quantity of dry salt per cubic foot of wood. So this is what the inspection agency has looked at and actually tested for. Okay, that makes sense. So they look at the quantity of dry salt per cubic foot of wood. So this is for treated wood. What is dry salt in treated wood? Okay, so it's just a preservative. So this right here stamps and says this is how much preservative is in this wood, and it has been tested. The material has been kiln dried after treatment. Okay, that makes sense. So if treated lumber is kiln dried, you can paint it, and that's why they price stamp this on there. Otherwise, you need to let it dry in the air. So it'll say on the stamp for pressure treated lumber, it'll say if it's dry. The type of preservative used for treatment. Okay, so yeah, there's different preservatives that treated wood can have, and this stamp tells you exactly what preservative is used in it. They used to use arsenic as a preservative in treated wood, and they found out that it was poisoning people, so they made that illegal, I believe. Don't quote me on that because I'm not an expert. Foundation use. FDN indicates all-weather board. LP2 indicates above ground use. LP22 indicates below ground use. Okay, so we have three different ratings that show three different applications for the treated wood. Quality mark of the American Wood Preservers Bureau. I don't know what that means. That's the one I'm actually not sure. Earliest date indicates the year the material was pressure treated. That makes sense. And then that's everything on our treated lumber quality stamp. It's a lot of good info. I'm glad I know it. So this is a bunch of diagrams for different applications of treated lumber. Makes sense? Cool. That's handy. So I have something visual to like compare it to. So it looks like they put it on top of foundations. You might put it on top of, so you'll pour a pad of concrete and then you'll put a post on that. And that post that's on the concrete has to be treated again because of the moisture issues with concrete. And I don't know why that happens. I'm kind of curious. Shows me a diagram of a wood framed foundation. So some foundations don't even have to be on concrete. And in this particular case, they're showing treated wood being used there. They're showing treated wood being used on a balcony, which also makes sense. Cool. Standard lumber sizes. Okay, so it looks like we're moving on segments. So we have a chart here. Standard lumber sizes based on Western Wood Products Association rules. Interesting. I'm not sure what I'm looking at. It's definitely a chart of some sort, but like, what does it all mean? Seventh site, you really need mental health support. Yeah, you know, that's a good point. I'm actually there was this coach I met at a networking event. I'm gonna call her up. She's like a relationship coach, and I'm like, can you help me not be single? And she was like, sure. And then, so I'm gonna see if I can trade handyman services for her coaching services. It'd be kind of awesome. So okay, now do I decide, do I want to read this chart? This chart looks like it's telling me, if I had to guess, I don't know. I don't know what this chart's telling me. I'm gonna ignore it. I'm gonna keep moving on so I don't get stuck on anything. I'd like to keep momentum with my education. Okay. Framing. This is going to be a good one because every house is framed, and I open up walls sometimes and I want to know what's happening in it. So, different categories: building loads, design values for structural lumber, span tables for standard, I don't know, S4S lumber, span tables for rough lumber, spans for prefabricated wood eye joists, span tables for stressed skid panels. I don't know what that is. Span table for stressed skin panels, span tables for plank floors and roofs, span tables for, where am I? Glued laminated beams, span tables for steel beams, post and beam framing, balloon framing, platform framing, framing details. Okay, a lot of good info. I think the span tables are probably like the least value. I'm not doing a lot with structural with my handyman business. And so I don't think I need to know exactly how far each thing can span. I think post and beam framing is worth looking at in depth. Um, I mean, I'm just not doing much with structural, so I don't know if it's even worth focusing on that right now. Balloon framing, platform framing, and framing details probably worth doing. So let's start diving in. About 21 minutes in. So far, I think honestly, so far I'm liking this. I feel like so I'm working through material way slower than previously, but I do feel like by explaining it, I'm getting a deeper understanding of it. At the very least, it's something different than my normal studying and less painful, and the time flies faster. So like, I can't complain. And I know it's not exactly valuable streaming, but like, people don't have to watch. So if you don't want to watch, certainly don't watch. It could be interesting to like set up a consistent stream where other people that are like, I don't know, hustling handyman or construction guys could like study with me and comment. I don't know, that would be kind of cool. I don't know how if that's realistic, but like if I streamed consistently, mark like typed in like studying to be a handyman or studying for my builder's license or study with me for my builder's license or something and got, 10, 20 people in there were that I could like digest this and communicate it to. I don't know, that'd be kind of an interesting idea. Um, so getting into framing. To make a human how has your journey been? I haven't seen anything from you since you moved to Michigan. I've been doing some like live streams and stuff. Journey's great. I mean, unlocking new levels of hustle, making stuff happen. I am studying for my builder's license right now, which, if you don't know, I started a handyman business. So I'm like, let's grow this thing. Let's make some money. So the goal is get to 10K a month. And I'm studying for my builder's license, which will give me more credibility and stuff. And I started to stream so I can like study it, digest it, and then communicate it. And I think that's going to help me learn more quickly. So it's a bit of rambling and whatever, but like, I don't know. I think it's a valuable way to learn. At least I'm trying it. So to make a human analogy, the frame of a building is its skeleton. To assure that this skeleton is strong enough, we need to know specifically how much weight it will support. The building loads, knowing the loads and design values, maximum allowable loads. For a structural member, we can consult the span tables for S4S lumber, surfaced on 4 sides, or for rough lumber to select the proper size joists and rafters. Okay. That makes sense. That makes sense. So this is basically you need to build your house strong enough to support the loads that are expected. Um, and to figure out how much lumber, what size of lumber to use, you use span tables and design values. What's good? Hello from the thumb of Michigan. Hey, what's up, APM Auto? Good to see you here. Do I do roofing? No. Not right now. So roofing, the reason I don't do roofing, because I've had people ask me to do some stuff on roofs. The problem is if you mess it up, you don't know for like 5 years and it's a lot of damage. So if you have a leaky roof, it's rotting stuff out and you most likely won't know for a while depending on the severity of the leak. So it's kind of high risk and it's hard to see when you're doing it wrong. So I might do a $20,000 roof and not know it's bad for 3 years and I don't want to be responsible for that. So yeah. Go work with the Amish. Is it Amish or Amish? I think you say that Amish. Dude, I have a buddy. He keeps telling me I'm Amish because of the way I talk. My roof costs 20K. I'm doing it myself. Well, yeah, roofs. So I met a guy that did 100 roofs last year, which is cool. I would love to work 1,000 square foot shed. So that's dude, that's bigger than a shed. I'm just putting that out there. 1,000 square foot is like 100 by, or no. I, am I tripping out? That's 100 by 100, isn't it? Or no? No, 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 no. 1,000. Why am I tripping? 31 by 31. Ah, okay, okay. Or 26 by 40. Yeah, that's not, I mean, I guess I'm not too surprised by that. Roofs are expensive. But yeah, how's it going? Is it going well? Yeah, 26 by 40 is like a decent sized shed. Makes sense. I'm gonna be touching it in and out with my studying because I have to be focused. Builders are increasingly turning to joists made of plywood, so span tables for prefabricated wood eye joists are included here. Yeah, so need your span tables to know what size of wood to put in your house to make sure it's strong enough for the expected loads. People are going away from normal joists out of like typical lumber and they're going into prefabricated wood eye joists. It's built in the 80s, held up till now, but I assume you have to now you have to replace the roof. That's yeah. It's a lot of work. I mean, I dang, the guy I mentioned doing 100 roofs last year, I would love to work on his crew for like 6 months. Just like get like 20 roofs under my belt or whatever. Well, yeah, 6 months, he did 100 in a year, so 6 months would be 50. But it'd be cool. Oh, someone decided to cut your main beam in half to install HVAC. Yeah, that's where you got the crackhead Joe handy guy. Handymen have a terrible reputation. It totally could have been a handyman. I have a steel beam to replace it. Yeah. Yeah, and if you're gonna be up there doing roof work, it's like you may as well fix the other big issues. Normal sheathing materials covered in Chapter 7. However, stressed skin panels, a modern development structurally combining the strengths of eye joists or rafters and sheathing, are discussed in this chapter. Stressed skin panels. I've never even heard that. I'm gonna have to look that up. Stressed skin panels. Weird. It's kind of interesting. They are similar to SIP. So that's SIP structural insulated panel, I think. Except the skins may not be structural. They are typically used to provide a specific look inside or outside, or both, depending on the skin and installation method. I'm not gonna focus on that too much. I'm gonna move past that. Span tables are given for plank floors and roofs, often used with the greater than usual joists and rafter spacing that results from post and beam framing. I swear, sometimes I read a paragraph and I'm like, what did I even just witness? Span tables are given for plank floors and roofs. Okay, that makes sense. Span tables is how far they can span and still provide the strong skeleton that a house needs to be. Often used with the greater than usual joist and rafter spacing. Greater than usual would be like usual is 16-inch, I think. Greater than usual. Post beam frame. Weird. Bought the property for about 56. It's 82 acres. Dang, that's a big property. That's so dirt cheap for that big of a property. 3 bedroom, 1 bath. with two-car garage and the shed in the back. Yeah, can I if my handyman business fails, can I? Oh, 0.82, 0.82. Okay, I was like 82 acres. Um, anyway, oh, if my handyman business fails, can I live in your garage just like as a backup plan? Often use hmm. When loads become too large for ordinary timbers, you can turn to glued laminated beams and even steel beams. Okay. So, yeah, if you need the skeleton to be stronger and wood timber is not cutting it, you can go to laminated beams or steel beams. This chapter includes simple span tables for both wood beams and steel beams and laminated timber beams. Okay. My cars live there and my sandrail, I don't know what a sandrail is, but lives in the shed. I'm just saying I could live in the shed. I'm kind of a hustler, so like you might be able to get some rent there, bring in some extra revenue. If you're married, the wife can buy an extra purse every month. What, gotta think about dune buggy. Dune buggy. I don't even know what a dune buggy is. I'm gonna have to Google that. So, I'm just saying you should let me sleep in. Oh, dang, dude. Can I drive that? I'll sleep in the dune buggy. Um, I'm not sure that's going to help my sales pitch. I won't sleep in the dune buggy, but I will take it out and make sure everything's running great on it. That's funny. That looks like a ton of fun to use. Okay. If you are remodeling an older home, you may be dealing with balloon framing. If your home is less than 50 years old, you'll probably recognize its platform framing. So you said your house is, I don't know if you gave the age. I think you did. Built in the 80s. So this is saying, based off this, your house should be 50, it would be that would be less than 50 years old. So your house is probably platform framing. So they must have switched from balloon framing in where the studs run all the way up to the roof trusses, or yeah, roof trusses. They switched from that to platform framing in B, like 1935, and it's probably like average. Home is roughly 1950, shed is 1985. Yeah, okay, so your home is probably balloon framed then. So your studs probably run straight up to your roof rafters. Okay, that's interesting. That makes sense. It may not. I don't know if it's exact. Not. I don't know if it's an exact science. Regardless of your framing system, you should find the section on framing details helpful, especially the section on framing for super insulation. My dad's home is 1800s. How has it lasted that long? What? That's so. I didn't even know they built houses back then. I thought they lived in like mud huts. I'm kidding. But that's an old house. Building loads are the weights. Building loads are the weights a building frame is required to support or resist. There are four types of load. Dead load, the weight of the building materials alone. Live load, the additional weight due to occupancy, i.e., the weights of people, furnishings, and stored materials. Snow load, the weight of accumulated snow on the roof of the building. Wind load, the force of the wind pressure against the exterior of the building surfaces. Okay, so four types of load. Dead load is just the house alone. Live load is when there's people and stuff in it. Snow load is when there's snow on the roof. Wind load is when the wind is pushing it side to side. And then it also shows a arrows pointing on where the different loads would be. So live load is down, dead load is down, wind load could be side to side or up, snow load is down. Maintenance does wonders. Lived in one from 1850s myself for a while. Yeah, that's pretty cool. I'm surprised. I didn't even honestly didn't know people still lived in houses from then. A lot of the houses that I do some work at is like they shouldn't have. I don't know. I don't know that they're gonna make it another 50 years because they're just like big problems in them. I'm usually working for like property, different landlords and stuff, and sometimes the houses are just they're just not that good. They're kind of lower quality, but I don't know, gets the job done, I guess. I'm gonna go for another 5 minutes and then call it. I might have to do a short video of the house. There's moldings around the top of the upper bedrooms. There's also hand carved ironwood. I've heard of ironwood, but that sounds pretty cool. Dang, ironwood's awesome. It looks sweet. Victorian era homes are everywhere in the Midwest. Yeah, well, I'm not gonna pretend like I understood what that sentence was. Victoria, Victorian era homes. Victorian. Okay. The time period of Queen Victoria's reign from 1837 until her death in 1901. And then Midwest. I'm literally just Googling the terms I didn't understand. Refers to the north central region of the United States. So I think that would put Michigan in the Midwest. Yeah, okay. Dang, I took your thing I didn't understand. I Googled it, now I understand it. Great, that's beautiful. Back to studying. So, dead loads. For floors and roofs, add the weights of the building components, using the table at the right to find the total dead load in pounds per square foot. Oh, interesting. You can literally just like do the math on how much each building material weighs, and you can figure out what the dead load is. For example, a first floor is framed with 2x8 joists, spaced 16 inches on center, covered with 1/2 inch plywood, and wall-to-wall carpet weighs 3 pounds per square PSF per square foot. 3 pounds per square foot. PSF means pounds per square foot. Plus 1.5 PSF plus 0.5 PSF equals 5 PSF. Okay. So yeah, they have a table here. You can literally just like calculate how much your house weighs, apparently. That's kind of cool. Huh. Live loads are specified by building code. The table on the following page is representative of the major national codes, but verify particulars with your local building inspector. So live loads specified by building code. That makes sense. Verify it with your local building department. That makes sense. Snow load is the greater of the following. Minimum roof live load, including the effects of snow and roof construction / repair activities found in the table. Design snow load 0.8 times the 50-year ground snow load from the map below. Hand-carved ironwood staircase and crown moldings that match the staircase and carvings. Yeah, that's gotta be nice. Ton of work though. Just think about somebody like however old your house is, somebody back then just carving away. Michigan I'm in Iowa, which is also Midwest. Okay. 2x4s, 2x8s hold the weight. Going for GC license. Yeah, it's not called a general contractor's license, but you need to be a licensed builder to do general contracting. My great aunt got hers to prove the men in the family weren't as smart as they thought they were. Lol. It's the ultimate vengeance story. I don't know if that's actually productive, but it's kind of funny. Yeah, so I'm going for my residential builder's license. I can pull permits. I could be a GC if I wanted to. I can have employees work for me and do projects. I can do projects over $600 legally. So there's a lot of benefits to getting a GC license or not a GC, but a residential builder. And it builds credibility with potential clients. So I'm gonna go through the snow load again because like snow load is important, and I just read this and I'm like, I don't know what I'm even. Snow load is the greater of the following. So I think it looks like this is telling us how to figure out what the snow loads or not what the snow, what the building loads are going to be. So the snow load is going to be the greater of the following, and then it's going to list off a few items, and it's going to be whatever item is greater. So that makes sense. Minimum roof live load, including the effects of snow and roof construction slash repair activities found on the table on the right. Okay. Design snow load, 0.8 times the 50-year ground snow load from the map below. Dang, I'm not getting this. So it's going to be the greater of the following. Minimum roof live load. That's something I don't understand. What does minimum roof live load mean? I know what live load means. Oh no, I know what that means then. The minimum roof live load would be when there's people and equipment building it or up there. Okay? And that's what it says, including the effects of snow and roof construction or repair activities found on the table on the right. Hmm. Roof live loads. Hmm. I'm not getting it. I feel like I need to get this. I'm gonna pull up ChatGPT as my assistant. What are snow loads on houses, and how does it relate to construction? Snow load refers to the weight of accumulated snow on a building's roof, which is a critical factor in structural design and construction. If a roof isn't properly designed to handle snow loads, it can lead to sagging, leaks, or even collapses. Well, I'm out for time, so I'm gonna wrap up, call it a good day of studying, and then, I don't know, maybe I'll host another stream, do the same thing. We'll see.